Ismail is here. Today we're going to start the study 3.4 exponential and logarithmic functions, okay, or equations. Now we're going to learn in this lesson two things. The first thing, we're going to learn how we can apply one-to-one property for exponential function and how we can apply one-to-one property for logarithmic. So we are going to learn for the exponential and logarithmic because logarithmic is the inverse for the exponential. Now the first thing here, one-to-one property. What's the one-to-one property actually? So if we read here, let's read here together. In the lesson 3.2, exponential function were shown to be one-to-one. Recall that we know that the function is one-to-one when you have no y value is matched with more than one value of x. Means every input should has one output. Okay, so any input it should has output. So this is one-to-one. Now we can use this rule to identify the exponential part. For example, look to this key concept. If I have, of course, b cannot equal 0, or sorry, b greater than 0, and b is not equal 1. We know that this is the rule. The rule said when b base to the power of x, it should equal to the b base to the power of y. So we can cancel the bases. So the answer is x equal y. So this is the rule. For example, look to this one here. 3 equal 3. Okay, so this base similar to this base. So we can just cancel the 3 with the 3. So the answer is the power x equal 5. Okay, same thing for the inverse. If we do the inverse for this one, when I have log x equal 3, we can rise both sides by to the 10 to the power of the log equal 10 to the power of 3. For example, so let's say I have log 7, okay, x equal, for example, 4. So how can I solve this equation, or how can I solve this? I can use look to the base. The base is 7. So what I have to do, just 7 for both sides. 7 to the power of log 7 x, okay, equal then 7 to the power of 4. So now I can cancel this log with this 7. So x is equal 7 to the power of 4. One more example. So let's say I have log 3x equal 7, or let's say 8. Okay, so I can solve this one by, what's the base here? The base here is a 3. So I have to do 3 to the power of log 3x equal 8. Sorry, not 8. 3 to the power of 8. 3 to the power of 8. So I cancel now this log with this log. So we mean x is equal to 3 to the power of 8. Okay, so this is how can I solve the inverse, by applying for both sides same base. Now let's go to the first example. Solve exponential equation using one-to-one property. Let's solve each equation. Now first thing, look to the bases. So the base here is 6, the base here is 36. Now we need to change the big base to become as the small base, to become as 6. So now 36 can be written as 6 to the power of 2. Then after that, after I do that, I can use distributive property, okay, which is it will become 2x plus 2. Then I have, look to the base here. The base here is 6 and the base here is 6. So we can just cancel them together. So I mean 2x plus 2 equal x plus 6. Now just solve this equation. If you need to solve it, always take the small x's to the big x's. Minus x minus x. So we cancel these two x's. So it become now x plus 2. Then we minus 2 from both sides. So we cancel this 2. So x is equal 4. So this is how we can solve that question. Now question number B, we have many ways to solve it, but let's use any way if you like. Okay, so the first way, we need to switch the 64 to the base, or let's say the first thing, let's flip 1 over 2. So let's flip this. We have the rule said when you have a over b to the power of n, we can just flip it b over a to the power of negative n. Or so you can do it like this, or you can do it like this. Now the question in this form, so I can replace it in this form. So it become now 2 over, sorry, let me flip now the fraction, 2 over 1, all of that to the power of negative c, right? So 2 over 1 means what? 2 to the power of negative c, because any number over 1 means same number, equal 64. 64 can be written as 2 to the power of 5, okay, to the power of 1 over 2. So now 2 times, so now we can multiply the power 5 times 2, so it will become 2 5 over 2. Oh, sorry, it's not 5. It's 6. Sorry. Let me erase this. Okay, it's not 5. It's 6. 2 to the power of 6. So now we can multiply the 6 here, so it will become 6 over 2. 6 over 2 mean equal what? Negative c equal 6 over 2 is equal 3. So 2 to the power of 3. Now, do I have same bases? So this base is similar to this base. So I can cancel the bases. So negative c is equal to 3. Or we can just now divide by negative 1. So c is equal negative 3. Okay? So this is the answer. Now, let's solve this. So look to the base here. The base here is 4, small number. The base here is 6. 6 can be written as 4 to the power of 2. So now let's replace it. 4 to the power of x plus 2 equal 4 to the power of 2. All of that to the power of x minus 3. Now let's distribute the 2 for the x and for the negative 3. So it will be 4x plus 2 equal 4 2x minus 6. Now, if you look here, we have same bases, 4 and 4, so we can cancel the 4's together. So it becomes x plus 2 equal 2x minus 6. Now, take the small x's together, so minus x minus x. So we cancel this 2. 2 is equal x minus 6. Then we plus 6 for both sides, so we cancel this x's. So x is equal 8. So this is the answer. Now try to solve this question 1a, 1b, 1c. Okay, and if you need any help, please let me know. Okay, now we'll go to the second example. Example 2. Solve logarithmic equation using one-to-one property. Okay, now how we can solve this one? Look to the example. The example here is saying len. So because I have len, we have this rule. Always when I have len, e is equal 1. So because this one cancels this one. Or we can say e to the power of len is still also equal 1. So we cancel this with this one. Okay, so now if in order to cancel len, what should I do? I have to do e for both sides. So it will be e to the power of n and e to the power of 6. So this is what I did here. E to the power of len x equal e to the power of 6. So now we cancel the len with the e. So it becomes now x equal e to the power of 6. E to the power of 6, you can do it in the calculator, you get 403. Now let's do this. Before you're doing the properties of the logarithm, start by simplifying. If you can move something to another thing, or plus or minus. I can here move 6 first, minus 6 for both sides. So we cancel the 6's. So now 2 log 5x equal 18 minus 6, which is equal 12. Now I need to isolate log. I need to isolate x. So what I have to do with the 2, I can divide by both sides by 2. Divide by 2. So I cancel this 2 with this 2. It become log 5x equal 6. Now, if you remember, when I have a question similar to this, I can convert it to exponential. So now let's convert it to exponential. What's the base here? When I have no base, so this is common logarithm. Common logarithm means common base. 10 to the power of 6 equal 5x. Now let's solve this one. It's easy to solve. We need to isolate x. So now we divide by 5. We divide by 5. 5 with 5, x is equal, it will become 200,000. Okay, so this is the answer. Now let's solve the last one. The last one is easy and simple. We can just convert it to exponential from the first step, but don't forget, use the properties. We have a product property, we have quotient property, we have power property. Can I use one of these first before I simplify? Yes, I can use the power because I have power here. I can take the power before the log. So it will become 3 log 8x equal 12. Then I need to isolate the log, so I have to divide by 3 for both sides. Divide 3. Cancel these, so it becomes log 8x equal 4. Now convert it to exponential. It becomes 8 to the power of 4 equal x, which is the answer. X equal 8 to the power of 4096. So this is what x equal. Okay, I hope you understand this. Now it's your turn. Try to solve this question, and the answer is in front of you. Solve them, then try to check the answer. Now, we finished from the one-to-one property of exponential. Now let's go to the one-to-one property logarithmic function. So logarithmic function one-to-one property, same thing, no different. Let's read the key concept. Always b should be greater than 0 and b cannot equal 1. So now when I have log, look to this one, log base b and equal log base b. So when this log equal to that log, we can cancel the log together. So x is equal y. Okay, so for example, look to this one, log 2. Look to the base here. The base here is 2 and the base here is 2. So we cancel log 2 with log 2. So it's remain x is equal 6. Same thing also with the len or with the e base. So when I have e to the power of y equal 2, what can I do to cancel the e? How can I cancel this one? I can do len for both sides. Len here, len here. So now len cancel the e. So it becomes y is equal len 2. So this is the answer. Okay? Now, let's go to the example. So example number 3. Solve exponential equation using property. Solve each equation. Look to the first one. First thing, I have to use one of the properties that we learned. Power property, product property, quotient property. And I can use here the product property. When I have this log, okay, multiply, added to that log. So we can do that. This is a product property. So we can combine these two together by multiply them. Because a product property. Okay, product property. So this is what you can see. This is the same. This is a question and this is the question. This is not a step. Now the first step is here. Well, this one is the product property. So after we multiply them together, I have now same bases. Can I cancel the bases? Yes, I can cancel the bases, or we can use distributive property first. 3 times x and 3 times negative 2, so it becomes 3x minus 6. Now I have same bases, this base similar to this base. I can cancel this one with this one, so it remains x equals 3x minus 6. Now I can just take minus 2x, okay, minus 3, sorry, not minus 2. Minus 3x, sorry. Okay, minus to isolate the x in one side, minus 3x for both sides. So we cancel this with this, so x minus 3x equal negative 2x equal negative 6. Then we can divide by negative 2, divide by negative 2, then we cancel negative 2, so x is equal 3. Okay, so the negative with the negative goes together, so it's equal 3. Now let's solve the second one. For the second one, look to the bases from the first step. The base here is log 3, and here the base is also log 3. Can I just cancel them from the first time? Yes, I can just cancel them. So it becomes now x squared plus 3 equal 52. Now simplify this. So it becomes negative 3 for both sides, negative 3 isolate x. So x squared is equal 52 minus 3 is equal 49. Then I use square root for both sides, square root, so I cancel the square with the square root. X is equal positive negative 7. So I have now here to answer positive negative. Now try to solve these two questions. Take your time to solve them, and if you need help, please let me know. Now let's go to the example 4. Example 4, look to the question A. Question A is saying 4 to the power of x equal 13. So as I can simplify 13 to become similar to the base of something. Or you just think like that. 13 can be written as 4 of something. No, it cannot be. So what I have to do to solve this exponential equation? Okay, so I can use log for both sides. Okay, so let's do log for both sides. So the first step, okay, log for both sides. Okay, so now log here and log here. Then after that, we can use one of the properties, which is the power property. So we can take this x before the log, so it becomes now x log 4 and log 13. Then what can I do? To isolate x, I can divide both sides by log 4. So log 4 here and log 4 here. Then you can cancel this one with this one. So x is equal log 13 over log 4, which is equal 1.85. Now let's solve question B. Always when you see e, the exponential, think about what? To learn both sides. Okay, so now as I can see here, we have e here and we have 6 here. So let's learn both sides. Learn e to the power 4 minus 3x equal learn 6. Now when I have e with len, they cancel each other, so it becomes 4 minus 3x equal len 6. Now we need to isolate x, so I have to do now minus 4 here, minus 4 here. Can cancel these two together. Negative 3 equal x, negative 3x len 6 minus 4. Now I can divide by -3 for both sides, divide by -3, divide by -3, so we cancel these. X is equal ln 6 -4 over -3. Or you can just find the answer by 0.736. Okay? Or, because the question, read the question, guys, always read the question, round to the nearest 100, because it's saying round to the nearest 100. We know that when I have 0 point, for example, 5, 3, 4, 6, so this digit here, 5, represent the 10th, this digit here represent the 100, this digit here represent the 1000, okay, and this 0, which is the before the decimal, represent the ones, okay. So because it's saying round to the nearest 100, so we need to ignore all of these and we need to round it to this one, so we take only two numbers, and we can see that 6 can round the 3 to become 4, so the answer is equal 0.74. so this is the final answer. Now try to solve these three questions down for A, for B, for C, and let me know if you need something. Now let's do question example 5 and example 6. Solve each equation round to the nearest 100. Okay, I need bigger space for the first equation, so let me just give you a big space for that. Let us start solve this equation. Now we have here base 4 and we have base here 3. So I can't simplify any of these bases, so I need to log for both sides. If you can log for both sides, log here and log here, or you can len here and len here. It's up to you. You are free to use which one you need. Okay. So for easier to write, I will use len, not log. Okay. So now let's len for both sides. Len 4 to the power of 3 x minus 1 equal len 3 to the power of 2 minus x. Okay. Now I can use the power property to take the power down. Okay, so I can take this one here, so it will become now 3x minus 1. Okay, all of that multiplied with ln 4 equal, same thing with this one here, so it becomes 2 minus x times all of that multiplied with ln 3. Okay. Now, after I take the power property, I can use now distributive property. So 3x, so it will become 3x times ln 4 and 3x times -1, so -1 ln 4. Then equal, same thing on the other side, 2 ln times, 2 times ln 3, okay, and -x times ln 3. Okay, now the next step is to take the common factor together. So which one is the common factor? We know that if I have, for example, 2x plus 3, okay, equal 4 minus x. So which of these are the common factor? The common factor is which term has x's. So those are a common factor, right? And those are a common factor. So what I need to do, I need to take the 3 to the 4, and I need to take the negative x to the other side. Same thing happened here. Which term of these has x? The first term here has the x, and the last term here has x. So I have to put these two terms together in one side alone. Same thing with this term here. I don't have any x here, so of course this term similar to this one, because also both of them, they doesn't has any like term. So I need to take them together. So let me take this one to the other side, and let me take the -1 to the other side here. So let's replace both of them. So now to replace both of them, we will write 3x ln 4, this one minus, so it will become positive x ln 3 equal the other one 2 ln 3, and this one will become positive ln 4. Okay, so I think this step is clear because we're taking the like term together. Now think about if I need to isolate x, because my question, it's saying solve. What's the solve mean? Solve mean I need to find x equal something. So I need to isolate x. So as I can see here, I have x in this term and I have x in this term. So I can take x as a common factor. So let's take x as a common factor. So x 3 ln 4 plus ln 3 equal 2 ln 3 plus ln 4. Now, if we can reverse the power property, okay, which means I can now take the 3 to the power of 4, and I can take 2 to the power of 3. So now the question will become x times ln 4 to the power of 3 plus ln to the power of, sorry, and ln 3, okay, equal to ln 3 to the power of 2 plus ln 4. Now I need to find the x, so I have to divide both sides. Okay, divide ln, ln 4 to the power of 3, okay, plus ln 3. We do the same thing on the other side, ln 4 to the power of 3 plus ln 3. So I have to write 3 here. So we can cancel now these two together. So now x is equal ln 3 to the power of 2 plus ln 4, all of that over ln 4 to the power of 3 plus ln 3. So we can get the answer, which is ln 36 over ln 192. So x is equal 0.681 because it's saying round to the nearest hundred. So 1, it's not giving the 6, not giving the 8, so the final answer without the 1. So the answer is equal x0 equals 0.68. I hope you understand this. Now let's go to solve this one question here. So to solve the example 6, we can solve this one. If you look to the first equation, this one is similar to the equation ax to the power of 2 plus bx plus c equal 0. So this is a quadratic formula. So we know that to solve the quadratic formula, we need to do what? We need to factoring. So factoring, okay, is to find the factors of c that can be added to give you b. But here I can't, because I had e to the power of x and I have e to the power x squared. So what can I do here? I can make the question more simpler. To make it more simpler, I need to change e to the power of x to any letter. So for example, let's identify the e to the power of x as u. Okay, so let's say u is equal e to the power of x. So now any e to the power of x, I need to rewrite it in term of 2. So now here it's saying u squared, so it will become u squared plus 6 e to the power of x, it will become u minus 16, which is equal 0. Now this is a quadratic formula. So now how we can solve the quadratic formula? What are the factors of negative 16 can give me b? So we know that 1 times negative 16, and we know that 2 times negative 8, or we can say negative 2 times 8. So this pair can give me positive 6. So we need to write now u minus 2 and u plus 8. Okay, equal to 0. Now after I know these two values, okay, I need just to equal the first u is equal negative 2, the second u is equal negative 8. Now we didn't still finish yet. I know that u is equal what? U is equal e to the power of x. Now, so now replace u with e to the power of x, so it will become now e to the power of x equal negative 2. Now how can I remove e? To remove e, I need to ln both sides. So now I have to do ln here, okay, ln e to the power of x equal ln negative 2. So now I can cancel the ln with the e, so it become e equal ln negative 2. We know that when I have a negative, it's undefined answer. Okay, so no answer here. Now for the second one, because it's a negative, you know that the negative always is undefined. Now for the second one, let's do it. E to the power of x equal, sorry, this positive 8 should be positive 8. Sorry. Oh, okay. It's my bad. This one should be negative, and this one should be positive. Sorry, this one should be positive, not negative. Okay, so it's not undefined. So x ln 2 is equal 0. X is equal 0.69. Now for the other one, negative 8, this one is undefined, so it will be ln to the times e to the power of x, ln negative 8. Okay, so we cancel these two together. X is equal ln negative 8, so which is undefined. Okay, so we can do this one. This is the answer. Okay, I hope you understand this. Now I need you to try to solve the examples here. So try to solve example 5a and example 5b, then 6a, then 6b, and check your answer. Now let's go to the before the last example, example number 7. So as we can see in the example number 7, we have here the length. Okay, let me just let's say show how to solve the question. So as you can see here, this one, okay, and this one here, we can use the product property because they are sharing the same length with addition, so we can use the product property. So this is what you can see here. So the product property, this one multiplied with this one, and also for this one we can use the power property. We take the 2 to the power of 2, so it become like this. So now we can distribute the 2 for the x and distribute the 2 for the 4, so it will become 4 to the power 4x to the power of 2. Now I have the same basis, ln here and ln here cancel each other, so it become like this. Then I can minus 4x square and minus 4x square, or always make it like this, guys. Always make it in the standard form of the quadratic formula. It means the first term, okay, try to not make this term as negative. Don't do that. Always make it look positive. And to make this one always positive, we don't care about this term and this term. This term is fine to become positive, negative, but the important one is the first one should be positive always. Okay? So in terms of to do that, always take the small term to the biggest near. So this one, 4x squared and 3x squared, represent the first term. But if I take 4x to the 3x, so it becomes negative. So now I have to do the opposite. Negative 3x here, negative 3x squared here, so I can cancel this with this one, so it become now x squared. Okay, then I can take also for minus 4x plus 4 minus 4x plus 4, so it become, we reach this one here. Then we can factor this one by find the factors of 4, which is 2 and 2, negative 2, negative 2, so the answer is x equal 2. Okay, try to solve these two questions, same idea, and ask me if you need any help. Now to the last question here, same thing, but the difference here, we need to check for the extraneous solution, which is the excluded value. So we can do the same step. As you can see here, we know that we can do the product property for this one and this one. So the first thing, a product property, we multiply them together. Then the 2 goes down, same thing, and goes down, same thing. Then we can use distributive property for this one. So we distribute and we reach to this step. Now what's happened from the 2 to become similar to this? Now we know that if I have log 3 here and log 3 here, I can cancel them. But in this equation, look to this one. I have log 12 and here I have 2. So how can I have log 12 on this side? Okay, how can I have log 12 to both sides? So now you need to represent the number in terms of log. How we can represent a number in terms of log? We know that, do you remember this rule? It's when I have rule saying log b base to the power of x is equal what? This b cancel this one, so the answer is x. So for example, if I have log 7 and 7 to the power of 2, what's the answer? The answer is 2, because this one cancels this one. So if I tell you that log 12 and 12 to the power of 2, what's the answer? Also 12 cancel this, so the answer is 2. So I can represent any number by giving the same base of this log, okay, and we hide this number to become the power. So what's the log here? The log is 12. So on the other side, I need to put log 12, 12 to the power of 2, because 12 cancel the 12, so 2 is become 2, same thing. So I can represent 2 as in terms of log 12, 12 to the power of 2. So now we simplify. 12 to the power of 2 is equal what? Is equal 144. Now I have log 12 here, I have log 12 here, I can cancel this 2 12, log 12 together. So 12x squared minus 12x equal 144. So we minus 144 from both sides. So we cancel this 2, okay, minus 144. So we have this equation. Now, do I have common factor here? Yes, I have a 12 as a common factor. So we divide this one by 12, divide this one by 12, we divide this one by 12. So it become, then it become, after we divide, it will become x squared minus x minus 12 equal to 0. Okay, so now how can I factor this one? So the factor is this one is x plus 4, x minus 4 and x plus 3. So I have now x equal 4 and x equal negative 3. Okay, now to find the excluded value, you need to replace these x's for in the equation again. Okay, for every x, as you can see here. So I replaced the x with the 4, then you simplify. If you get the answer, so this is the correct answer, and this one is the wrong one. Okay, I hope you understand this, guys. If you need anything, please let me know. Try to solve now these two questions by yourself, and if you need help, try it in the comment below. Now try to solve the questions in the book, question 1 to 7, 11 to 20, 22, 37 on pages 196 to 197. Have a good day. See you. Bye bye.